This is question number 4 from the June 2013 SS06 paper, and it's a question on acceptance sampling. A metal company is involved in the production of ingots, each weighing 1 kilogram. A sampling process involves taking samples of size 4 at regular intervals. It's known that the standard deviation of the weights of 1 kilogram ingots produced by fur metal is 0.015 kilograms. The question asks us to calculate to 3 decimal places upper and lower warning and action control limits for the sample means and the sample standard deviations. And I'll talk you through the process. It says at the bottom that you're not required to plot these limits. However, I do think that it helps in the comprehension of the problem to plot these, particularly in light of what we need to do later on in the question. So the method for doing this is as follows. We're asked to do 95% for the warning limits, and we use table values here of 1.96 and minus 1.96. Our target value for production is 1 kilogram, and that goes across the middle of our chart. We then have an upper warning limit and a lower warning limit, and these are calculated by having the target value multiplied by the Z value that we get from the table multiplied by the standard deviation over the square root of the sample size. The 1.96 value comes from 0.975 from the table, because remembering if it's a 95% we're talking about 2 tails. So it's plus 1.96 lots of that to get the upper value and minus 1.96 lots of the standard deviation over the square root of the sample size for the lower warning limit, and that gives us values of 1.015 and 0.985. And I would suggest you just pause to make sure that you're happy in getting those values. For the action limit, we use a 99.8 value, and that's 3.09 from the table. That's the biggest value actually that we've got in stats tables, and they're taken from table 4, the percentage points of the normal distribution. So again, with it being 2 tail, we look at the 0.999 value, which is 3.009, and that gives us the upper action and lower action value, which again, using the same standard deviation over the square root of the sample size, gives us 1.023 and 0.977. For the sample means, we do a similar process, but this time we use values from table 12 in the formula book, which we find here. As you can see, the values that we've got, 0.04, 0.27, and so on, are taken, 0.09, I beg your pardon, are taken from here. Our sample size is 4, and because we're doing a control chart for the standard deviation, we use those that are taken from the E section over here. So our values for calculation purposes 0.09, 0.27, and so on, and we can see those in our calculations. Each time we simply multiply there by the standard deviation, and we achieve our values for the lower warning, the lower action, the lower warning, the upper warning, and the upper action level. And that concludes the first part of the question. So we will have done there the sample means and the sample standard deviations. Again, it said that we're not required to plot these limits, but setting them out in that way gives an idea as to the magnitude of the values, and certainly helps when we need to calculate with these bits, which are the second part of the question. So for part B, it says that 8 samples of 4 ingots were taken at regular intervals during a shift at fur metal, and the results in kilograms are given in table 2, which is opposite and overleaf. We're asked first of all to complete table 2, and then to state what action should have been taken on the basis of the results for sample number 5. So we'll now address part B in one go. To complete the table, we simply need to calculate a missing mean here for sample 6 and sample 8, and we do that by simply adding these values and dividing by the number 4. For the standard deviation, it's probably best to use the statistical function on the calculator, so enter these into one variable, statistics, and that will give the standard deviation there. On a question like this, if you want to just check that you're using the correct method and you have time, you can always put in values for a completed mean and standard deviation and just ensure that you get those values. So I've completed the two mean values, 0.980, 0.995, and the two missing standard deviations, 0.041 and 0.029. And that was B part 1. We were then asked for B part 2 to comment on these values with respect to our chart for the means and for the standard deviations. You can see that a value of 1.010 lies happily inside the warning limits, so that would be approximately here. So there would be no problem there in terms of us saying that the production there was on target. However, for sample number 5, if we look at this value, which is the standard deviation, and we have a look at our chart at the bottom for the standard deviations, you can see that 0.041 is actually above the upper action limit. This would require us to take urgent action and immediately stop production. For the second part of B, it then asks us to comment on the performance of the process over the 8 samples. A question like this would ask us then, or would require us to reflect on the process over the whole of the 8 samples. So if we look at the values, we simply comment as we go through and look for patterns that may emerge. So it might be that as we're going through, the mean is increasing or decreasing, and similarly with the standard deviation. Sample number 5 really is the first point of interest with respect to our standard deviation, because that's the first point at which we go in and we're required to take action. If we look at our values for the mean throughout, we just again compare those with the values that we've got for the upper warning limit, lower warning limit, upper action limit and lower action limit as we go through. So a response to that question would require us looking for general patterns that emerge, and certainly in instances like sample number 5 where we have to take immediate action. That's how you would answer that question, and that's why I prefer to draw those upper action and warning limits and so on in that particular form, because it's much easier then to compare those values and see where they lie on this. Indeed, other questions ask you to plot these and then to comment upon them. I'm now going to look at part C, which asks us the following. The production process for the ingots is later found to be operating with a mean of 1.004 and a standard deviation of 0.02. So different values from further up in the question. It asks us to find the probability that the value of a sample mean will lie between the warning limits. Well, the warning limits for the process are 0.985 and 1.015 that we found earlier. So this then becomes a probability question essentially to do with the sample mean, and probably most of you will then use the calculator function for this, and we'll get it into normal distribution mode and use the LUSM, our lower value 0.985, upper value of 1.015, our new standard deviation divided by the sample size, square root of the sample size, and then the mean of our production here, which is 1.004, and that gives us a value of 0.986, and that concludes the question.